Sequences and Series Part 1, an Introduction. In this part, we're going to look at a few definitions and some notation. So a sequence is a list of numbers that has a function rule associated with it. That's the definition we will use for this level of calculus. I like to think of my sequence a sub n as corresponding to f of n, where n is a positive integer, sometimes with 0. We could also write n as one of the natural numbers, sometimes with 0 also, which means n is usually 0, 1, 2, 3, etc. But I can really start at any n value 0 or greater. A simple example is a sub n equals 1 over n plus 1. And let's start n greater than or equal to 0. So we'll start at n equals 0. So we could list out the terms of a sub n. So a sub n would be a sub 0, then a sub 1, then a sub 2, etc., etc. Which means for the first a sub 0, we go back to our function rule and plug in n equals 0. So we get 1 over 1. For the next one, we plug in n equals 1 because we're dealing with a sub 1. So we get 1 over 2. And a sub 2, we plug in n equals 2, which gives us 1 over 3. So sometimes I like to think of a sub n as being like a of n, where a sub 1 is a at 1, etc., etc. Now, unless otherwise stated, we assume that a sequence is infinite in length. That is the underlying assumption for us. And a couple definitions which we used before when we did improper integrals, at least a similar definition. We say that a sequence of finite numbers, a sub n, will converge if the limit as n goes to infinity of that sequence is finite and unique. Otherwise, the sequence diverges. So let's look at our first example. Consider a sub n equals n over 2n plus 1. And we'll do n greater than or equal to 1. It doesn't really matter whether 0, 1, 2. Because we want to look at the limit as n goes to infinity of our sequence. Notice that every term, that is every individual term in the sequence, is finite. So all we got to do is look what happens at n equals infinity, quote unquote equals infinity, and we get the limit equals 1/2. There are many ways to do this one. You could do L'Hopital's rule if you want to do a formal way, but usually we can look at limits like this and just get the answer equals 1/2. Which means that our sequence converges because the limit is certainly finite and it's unique. So what does it mean by unique? Well, let's take a look at another sequence that's called b sub n equals negative 1 to the n. And we'll do n greater than or equal to 0. Now let's write out some terms. Let's start with n equals 0. So b sub 0 is negative 1 to the 0, which is 1. N equals 1, we get negative 1 to the first. N equals 2, we get negative 1 squared, the negative 1 cubed, etc., etc. So what happens way out at infinity? Well, we're going to get either 1 or negative 1. Both of these are certainly finite numbers, but it's not unique. Because way out at infinity, what will b sub n equal? Well, it'll either equal 1 or negative 1. Since we don't know which it is, we say that this sequence diverges because it's not unique. And let's talk briefly about series. A series is a sum of the terms in a sequence. You're probably used to it with sigma notation. Again, we can start with any n 0 or greater, where n is an integer. So I'll just put a random big N. Unless otherwise stated, they're infinite. And it's a sum of the terms in the sequence. And this series will converge if the infinite sum is finite and unique. Otherwise, the series will diverge. Let's look at an example. Consider the sequence a sub n equals 2 to the n, where our series will be the sum, let's start at 0 to infinity, of our sequence 2 to the n. For a summation, we're using our sigma notation. We start at n equals 0. We start here at the bottom and plug it in. We get 2 to the 0. Then we go to the next n, 2 to the 1, and then 2 squared, and then 2 cubed, and then etc., etc., etc. And the sigma says we need to add these terms together. Hopefully there's no doubt that the sum of all these terms is going to infinity, which means that our series will diverge because the infinite sum is not finite. Let's take a look at one more example. Let's consider the sum of negative 1 to the n plus 1 times 1 over n squared from n equals 1 to infinity. So we're going to sum the terms in our sequence. Plugging in n equals 1, we get negative 1 squared, so positive 1, and then 1 over 1 squared. Sigma says that we add. Now we plug in n equals 2, the next n value. I'll actually write that down here. So we start at n equals 1. Now we need n equals 2. So we get negative 1 cubed, which is negative, times 1 over 2 squared. And then we'll do n equals 3. We get negative 1 to the 4, which is positive, times 1 over 3 squared. And I think we see the pattern here, so I'll rewrite it in a nicer form. We get 1 minus a fourth plus a ninth minus 1 over 25 plus etc. I made a little mistake. Let me correct it there for you. It's not 1 over 25, it's 1 over 16. I will make the occasional mistake. Now, does this series converge or diverge? Well, we don't know enough now. But we'll see over the next few videos how to determine whether series like this converge or diverge.